Good morning all. Today I am going to say a case study about an MI patient. So the patient having a myocardial infarction and the patient has been admitted in an hospital. So the patient was having an MI in the lateral region of the heart. So it was planned to have an angioplasty and the stenting. So once the procedure is over, the patient is under unstable condition. So it is planned to have an VA ECMO. So that is called as Veno Arterial ECMO. So why it has been done is the patient needs an cardiac output support as his ejection fraction is very low and his heart and the lungs both need a rest for a few days to cope up and enhance its ejection. For that purpose, the doctors have been planned to take the patient for an VA ECMO. So how this VA ECMO will support the patient's blood flow as well as an oxygen flow, we can see with the circuit diagram. So here the patient is having a problem directly on the myocardium. I am concentrating the patient with the veins. Here the patient is having a femoral vein and the femoral artery. So how we are giving a flows to the patient is we are taking a blood from the femoral vein and I am supporting to give that in the femoral artery. For this purpose, we are draining the patient blood to an access cannula. This cannula is called as access cannula, where I am removing the patient's deoxygenated blood from the patient. So this access cannula will send the blood to a console which is called as centrifugal pump. Why? Because for an extracorporeal membrane oxygenation, we are using a centrifugal pump so that it will not cause any hemolysis further. So the blood has entered to an inlet and it exists to an outlet. This centrifugal pump is supported by a console and the drive wheel. So from the pump, the blood which is deoxygenated blood needs to be get oxygenated. So it goes to an oxygenator. So why I am drawing like this is the oxygenator is called as Vargas oxygenator. So the shape will be an integral Vargas shape, and this oxygenator has an integral bar. That means what does the oxygenator have an integrated heat exchanger, and it has an integrated arterial filter. So this oxygenator will get oxygenation through a gas port. The gas port will get oxygenated by an oxygen blender. To maintain the patient body temperature, so the patient was connected with the water lines. So the water lines will receive its water from a unit called as aquarium. So this aquarium will give a water supply to the oxygenator so that the heat exchanger will do its process to maintain a patient body temperature of 37 degrees Celsius. That is a normal core body temperature. So once the oxygenator will be getting an oxygenation, so it is a responsibility of a perfusionist to check whether the oxygenation has been adequately achieved. For this purpose, we want to monitor a pressure called as transmembrane pressure. This pressure should be almost about 20 to 50 mmHg. To monitor this pressure, we want to know what is pre-membrane and the post-membrane. So pre-membrane and the post-membrane pressure will give you a proper result of transmembrane pressure. So once this transmembrane pressure has been achieved, it indicates that you are giving a proper oxygen and the gas flow to the patient. And one more thing I want to add here, the flow from the centrifugal pump has to be monitored. Why? Because the centrifugal pump is pressure dependent pump, so it depends on the flow meter. So the flow meter is a device which is incorporated in the arterial outlet, right? So that or after the pump to monitor the level of amount of the blood flow from the patient. So once the blood has been oxygenated, it has been going to the patient. So it is returning to the patient through return cannula. So this circuit is called as VA ECMO, that is Veno Arterial ECMO. That means we are taking the blood from the vein and low. So to support the ventricle, automatically the ventricular heart rate is already low. So once the oxygenation will also be low. Why? Because the ejection from the heart to the lungs has been decreased in the patient. To support this, we are taking a breath, we are oxygenating, and we are returning to a return chamber. So how long we can do this procedure, and what are the other forms of indications for using an VA ECMO is about? We can go with the VA ECMO for other respiratory failure, like respiratory failure along with cardiomyopathy. So cardiomyopathy is a major condition where your ventricle will not be supporting to eject the blood. That is also one reason for going a VA ECMO. And if the patient is having percutaneous insertion, PTCA, the patient, this is what the case study we have taken today. That is percutaneous coronary angiography has been done due to ML. So another form of transplant is the heart transplantation. So if the patient is waiting for a heart transplant, but since he doesn't get the heart, we have to support the patient through an ECMO. So this ECMO is a long-term support. We are giving a long-term support through this type of circuit. So what is the end result of having this circuit is the patient will get an increased cardiac output, decreased afterload of the heart, increased myocardial oxygen consumption, myocardial oxygen rate. Automatically the heart will get weaned off with the help of this. So along with this ECMO support, we are giving a ventilating support to the patient and the anesthetic support. So once the heart has been on this support for a long days of 15 days, automatically the heart ejection fraction will increase. So you can able to wean off the circuit. So to off or wean off the circuit, you want to decrease the pump flow rate. You can clamp the rhythm cannula, and once the flow has been achieved and you are returned, you can clamp the access cannula and you can stop the pump. So to do this, you want to wait for each and every 6 hours of duration to understand about the ventricular function and its ejection and cardiac output. If everything is okay, we can take the patient out of this circuit. Okay. Thank you for listening.